Good afternoon, grade 9s. So today for our first lesson back, we're going to be discussing dividing polynomials by monomials. Now, hopefully you remember some of this terminology from your extension exercise, but if not, let's just go over a few of these words just to make sure that we fully understand them. All right, so we're going to talk about what is a polynomial. So a polynomial is an expression with two or more terms. Now let's remember that an expression and an equation differ. An equation has to have an equal sign while an expression doesn't. All right, these terms can have variables or the letters and numbers. Now the numbers can either be, if the number is on its own, then we call it a constant. And if the number is attached to a variable, then we call that the coefficient of the variable. All right. So then we are going to start talking about here, well then, if we know what a polynomial is, it's two or more terms, what is a monomial? Now we need to remember that a monomial, mono usually just means one. So it is an expression with only one term. So please make those notes if you need to. If you don't remember them from the things we covered in the extension activity, then there you go. So what we're basically doing is we're taking something with lots of terms and we're dividing it by something with only one term. So let's have a look at this to see if we can maybe understand it a little bit better. So let's go here to my pen. Okay, now this says, let's make a note of something. A over C plus B over C is the same as saying A plus B over C. Now what we need to remember is that when we add fractions, we need the denominators to be the same. So this would be A plus B over C. So let's just see if this makes sense to us. If I gave you guys this, it would be 1 over 9 plus 6 over 9. Well, I would just say 1 plus 6 over 9, right? Which would be 7 over 9. So imagine that instead of that 1, you've got an A, instead of that 6, you've got a B, and instead of this 9, you've got a C. That's basically what we're saying. So what we're trying to get to is that that means that we could write A plus B over C as two separate fractions, A over C and B over C. I hope that that makes some sense to you. If it doesn't, go a bit slow. So do you see how we went from two separate fractions to one? And the reverse is true too. We can go from one fraction to two separate ones as long as your denominators are the same. All right, I'm going to let that sink in for a little bit, but what we're going to do now is we're going to actually try and use this. So we're talking about using this in reverse. So initially we had two fractions that we wrote as one. Now we've got one fraction, and what I'm going to try and do is I'm going to write it as two separate fractions, because you'll notice at the top, if we were only looking at the numerator, it would have two terms, okay? So what I'm going to say is, instead of writing 5x plus 10 all over 5, I'm going to say 5x over 5 plus 10 over 5. Okay, so that seems to follow what we were saying earlier. So now let's see if we can simplify this. Well, what's 5 divided by 5? I'm hoping you're all saying 1, and then I've got an x left over. What about positive 10 divided by 5? I hope that you know that 10 divided by 5 is 2. So actually, we can simplify this to just x plus 2. I hope you remember from our extension activity in those videos, we discussed the fact that the 1 in front of an x, it doesn't need to be written. So we would much rather just write x plus 2. So here we go. The first thing we did was we split it up into 2. And once we split it up into 2, it was much easier to simplify each fraction to get something that was easy to understand. So the key here is, guys, we need to divide each term in the numerator by the denominator. So we need to split up that numerator, whether it has 1 term, 2 terms, 3 terms. It could have 6 terms. It doesn't really matter. We'll split them each all up and make them into their own fractions and then simplify from there. So let's just do a couple of examples to make sure we understand this, all right? So here, the first thing I'm going to do is I'm going to split all of these up. So 12y squared over 3 minus, now don't forget that there's a minus there, okay? 6y over 3 plus, and then 3 over 3. Now let's see if we can do this. Does 3 go into 12? I'm hoping you said yes, ma'am. It goes in 4 times. So So we've got 4, and then our numbers, our variables get left as they are. Then we put down our negative and we say 6 divided by 3, and hope you're all yelling 2. And then we've got our y, and then plus, so I'm going to put down the plus, 3 divided by 3. Well, 3 friends, 3 sweets, they each get 1. And now we ask ourselves, well, is this the simplest form? Can I simplify this any further? And I hope you can see that we have made it as simple as it can be, because these are not like terms. Here we have a y squared, and here we have a y. So they are not like terms. So that's our final answer. Alrighty. Let's see if we can do another exercise, another example. This one's a little bit tougher, so let's play with this one. Okay, so what's different here is you see that we have 2 fractions. This might seem a little bit difficult, but what we're going to do is we're going to carry on the same thing we've been doing so far. I'm going to split this one into 2, and I'm going to split this one into 2. Okay, so let's see if that makes sense. 8a over, what's the denominator for that one? Oh, it's 2. And then plus, now we need the second bit, 4. What's the denominator for that one? Still 2. And then I've got, okay, plus 18a, and now the denominator is no longer 2. Now the denominator that belongs to this one is a 9. And now we say a positive times a negative. Well, positive times a negative, different people, tough relationship, negative, okay. And then we've got a 9 divided by a 9. All right, so do you see that we took these 2 fractions and we actually split them up into 4 fractions? Because there were 2 terms up here, so those split into 2 fractions. And there were 2 terms up here, so that split into 2 fractions. Now let's see if we can simplify. 8 divided by 2, you're all yelling 4. The a stays where it is. 4 divided by 2, I hope you know, is 2. And then we're going to pop down this plus. 18 divided by 9, 2a, because we don't forget about that a. And then a minus 9 divided by 9 is 1. And we ask ourselves, is this as simple as it can be? And I hope you realize that no, it's not. We have some like terms here. We've got an a over there, an a over there, and a constant over there, and a constant over there, which means that we could probably simplify. So 4a plus 2a, so 4 apples plus 2 apples gives us 6 apples. And then 2 minus 1, well, we definitely know that. That's plus 1. Now we ask ourselves again, is this as simple as it can go? Well, this is an a and this is a constant, meaning that they are not like terms, so we're done. All right, let's see another example. Well, this one's looking a bit tougher. All right, so let's go through our first step. We're just going to say this term divided by the numerator. So we've got a k cubed divided by k plus 18k squared divided by k plus 18k divided by k. So that's the same as the previous step. Now what's different here is that instead of having a number in the denominator, we have the variable k. So let's see how that's going to impact our calculation. Well, if we remember our exponential rules, when we're dividing by things that have the same base, so here at the top we've got k to the power of 3, and at the bottom we've got k. I hope you remember that we can subtract the exponents. So here, instead of k to the power of 3 divided by k, we're going to say k to the power of 3 minus 1. Because remember, this exponent is a 1 over there. And then we've got a plus 18, because, well, the 18 is just going to hang out on its own. And then we've got a k squared, and we're going to minus 1, because again, there's a 1. And at the last term over here, we've got 18k, and it's currently to the power of 1 up there. And it's at to the bottom, it's the power of 1 too, so I'm going to minus 1. Now I'm going to get k to the power of 3 minus 1. Well, 3 minus 1 is 2, so I've got k squared. And then leave this 18 alone since there was no number in the denominator. 2 minus 1 is just 1, so I've got k to the power of 1. And then I've got 18 again. Okay, 1 minus 1, well, that's k to the power of 0. Now we could leave it like this, but again, we need to keep asking ourselves, is it as simple as it can be? And while we're not talking about like terms here, because that's k squared, that's k to the 1, that's k to the 0, there are some things we can simplify. So this is going to be k squared plus 18. And instead of writing k to the power of 1, we know that it's better just to write k. And then we've got 18, and k to the power of 0 is 1. And 18 times 1 is just 18. So there we go. So we've got this example sorted. Do you see that we don't have any like terms there, and everything is done there? All right, so we're going to head to one last example. So this one looks pretty similar to the previous one. We had 3 terms. Oh dear, why is that equals floating? So we had 3 terms, and so we're going to split them up. So we've got 2k to the power of 3 over 6k squared, because that's the denominator, plus 18k squared over 6k squared plus 18k over 6k squared. Okay, now here's the difference between the previous example and this example. This example, in the denominator, we have a number and a variable. So previously, we've either had a number or we've had a variable. Here we combine the two. So all we're going to do is we're going to divide the numbers by the numbers, and we're going to divide the variables by the variables. Okay, so 2 divided by 6. Now here's your little cheat. If you want to simplify that and you can't do it in your head, which I hope you can always put in your calculator 2 divided by 6, and you will see that it becomes 1 over 3, because 2 goes into the numerator once and 2 goes into the denominator 3 times. Now you can say to yourself, we can ask ourselves one of 2 things. We can either do the exponential way we did before, so we can say k to the power of 3 minus 2. Okay, so we can do it like that. There's no problem there. We'll get k to the power of 1. Or I'm just going to show you a little bit of a different way. Okay, we can say to ourselves, there's 3 k's at the top, because k to the power of 3 means k times k times k. So there's 3 at the top. Then k squared is k times k, so there's 2 at the bottom. Now, if we wanted to cancel them out, we would say, there's more at the top than there are at the bottom. How many more at the top? Just one of them. So I'm just going to write 1k at the top. Okay. Now we're going to do the same on this side. I'm going to say 18 divided by 6. Now, if you don't know, you can pop it in your calculator. But hopefully you know it's 6, 12, 18. So 6 divides into 18 3 times. And now we're going to say to ourselves, okay, we've dealt with the numbers, now let's deal with the variables. At the top, I've got a k squared. At the bottom, I've got a k squared. So it's a k times k at the top and a k times k at the bottom. Well, then they'll just cancel out, won't they? So there won't be k's attached. In fact, if you wanted to use your exponential rules like we did in the previous example, it would just be k2 minus 2. And k to the power of 0 is 1. 1 times 3 is just 3. So that is what we would have. So I like to say that we would just have a 3 from the 18 divided by 6, and we would just cancel out those exponents, those variables, because they're identical to each other. All right, then we go over here, 18 divided by 6. Well, spoiler from the previous one, we know that it's going to be 3. Now here we have to pay really careful attention. At the top, we've got a k, just 1k. At the bottom, we've got k squared, meaning k times k. So there's 2 of them. So I'm going to ask myself, if I cancel out, where are they more? Are they more at the top, or are they more at the bottom? I hope you agree that there's more at the bottom than at the top. So I would just say it's definitely going to be at the bottom, and there's only 1 more at the bottom. So it's going to be k. All right, now that one's a little bit trickier, and that seems to be one of the trickier ones that we're going to do. So I hope that it made sense to you guys, and I hope that you can go over this with a pen and paper and just make sure you understand everything that I'm doing. If you don't, please let me know. Just an email or a Google Classroom or a Zoom meeting away. All right, guys. So I just want you to mull over this, really go through these examples quite slowly on your own. Make sure that you understand, especially these ones where we're dividing by a number and a variable. Okay, guys, I hope that that made some sense, and good luck with this. Bye.